Okay, this is Math 2. We're going to do problems 30, 33, and 34. The first one says, in a right triangle, if sine of theta is equal to 8 over 17, what is the cosine of theta? Justify your answer. So your hint, it says, draw a right triangle and label the size accordingly based on the description of the angle above. So what we have to do in the first one is, I would prefer if you use the Pythagorean identity, since you guys know that sine of theta squared plus cosine theta squared is equal to 1. You're more than welcome to use it. Plug in sine of theta, 8 over 17, into square it, and then figure out what it has to be, what cosine of theta has to be to equal to 1. There's a fast way to do this, so you are still responsible for knowing how to do it this way. But since the hint says draw a right triangle, we're just going to take the hint because I want to save on time here. So here's your right triangle. Here's theta. And it says 8 over 17. So we have opposite is 8 and hypotenuse is 17. And that should be enough to go on. You can then set up 8 squared plus, I guess we can call this, I don't know, we'll call this x. X squared is equal to 17 squared. 8 squared is 64, plus x squared is whatever 17 squared is. I have no idea. 289. So then x squared is going to be equal to 289 minus 64, and we get 225. So x is going to be equal to second square root of 225, which is actually 15. I don't know why I did that. So x is going to actually be 15. So that's 15. So then cosine of theta is 15 over 17. And if you do it the other way, using the Pythagorean identity, then you should get the same answer either way. I would prefer if you had the decimal format, not the fraction format, but just to check to see if the fraction format works out, you should get 0.8823 rounded, somewhere around there also, if you actually did the decimal. So cosine 15 over 17. Okay. Next one, 33. Use the relationships found in each of the diagrams below to solve for x and y. Assume the diagrams are not drawn to scale, but you can still infer some information. State which geometric relationships you use. So for part A, we have intersecting triangles, and we do know, as far as the diagrams, is that they're not drawn to scale, but certain properties still do take hold. And the fact is that these two are going to be vertical angles. So you can easily find out what this angle is if you take away 70 and 41 from 180 in this triangle right here, which is what I'm going to do right now. 180 minus 70 is 110, minus 41 is 69. So this angle in here is going to be 69 degrees. So that means this angle here is 69 degrees. And then you can do the same thing. So 169 plus 58 is 127. 180 minus 127 is going to be 53 degrees right here. All right, so we're done with that. It says, what's the measure of the missing angle in the left triangle? Once you know that angle, calculate the measure of angle y. And then you're really using the triangle angle sum theorem. And here's the hint. You found that these two were congruent because you're using the vertical angles. Vertical angle theorem. Okay, I'm abbreviating that part right there. Okay, so that was part A of number 33. Part B. Oh, I forgot to click on the hint. Oh well, it doesn't really matter. Let's see, how would I do this? We have, that should be okay. Oh, did we forget y? Oh, my bad. Okay, sorry. So this is a line, so that means 69 and y are a linear pair. So if I take away 180 minus 69, that's going to give us 111. So y is really 111 degrees right here. My bad. Okay. X and y. So we have a triangle, and then we have some two parallel lines over here. I'm going to just lightly trace those out over here, and then it makes it a little bit more convenient to see that 47 in this corner here and x are actually alternate interior angles. So x is going to be equal to 47 by alternate interior angles. Okay. And then y is really the exterior angle in here. So if you do, let's see, 47 plus 32, that's 79. 180 minus 79, that's 101. So this angle here is 101, right? And 101, 32, and 47 all add up to 180 in this little triangle right here. So if you take that away from, well, you just basically have 79 degrees. So y is equal to 79 degrees. So y is equal to 79 degrees, just y 79, sorry, you don't need degrees. And your reason is linear pair. Linear pair. And the same, pretty much the same reason that we found in the previous one, which was you really use triangle angle sum theorem to actually figure that out. But I'm okay with linear pair, if 79 and 101 are a linear pair technically. Okay, part C. You have, oh boy, okay, so let's see what we have going on over here. Two parallel lines, a couple of transversals, so let's work our way over here first, down towards the bottom. So 127 is the same as this part right there, which means that this side is 127, right there. And then x is a linear pair to 127. So they're going to be 127, or sorry, 180 minus 127 is going to be 53. So this is 53 degrees. 53 degrees. So x equals 53. And your reason is we'll use corresponding angles to get there. And then, I don't know, I would just say linear pair. Sorry, I would just say bilinear pair, because 127 and 53 have to add up, are supplementary, right? So they are a linear pair. Okay, so we got to get to y. This is weird, it's a little confusing. How in the world? Oh, duh, there's an 83 degrees over there. Okay, so this one is the same here, this one is the same here, those are vertical angles. And then, but 83 and this one are corresponding angles, and then it ends up being vertical angle to this one. So technically y is also 83 degrees so this was a two-step process, right? It really is first by corresponding angles and then vertical. Okay. By corresponding angles and by vertical angles. Okay, part D. We have a triangle and we just have to find the sides. Oh, that should be easy enough. Hey, look, it's a 45-45. So you know what that means? By law, math law, technically this is a 90-degree angle. I know it doesn't look like it, but it is. It's 90 degrees. Yay! Because it has to be. If that's 45, that's 45, and 90, that makes 180. I don't care what it looks like, it's 90 degrees. So that means across from the 90 degrees is going to be our hypotenuse. Ooh, this is such a good problem. So that means 3 and y are technically our legs. Here's a leg, here's a leg. Okay. Well, we know in a 45-45, the two legs are technically congruent because it's an isosceles triangle. So this leg here has to be the same as that leg there, which leaves y being a value of 3. Oh, that's super convenient. So if that's 3, and technically we just need to solve for x. So you can take the long way if you'd like. 3 squared plus 3 squared is your hypotenuse. Technically that's x squared. We have 9 plus 9 equals x squared. 18 equals x squared. And then you will magically find out that it is actually 3 square root of 2. That's a 2 is equal to your x. So x has a value of 3 square root of 2. Done. Okay. All right, so that was 33. Now we're going to go on to number... Sorry, I should probably zoom out. That was 33. So that was the end of that one. And then 34. Solve the quadratic equation below. Check your solutions with the calculator. Okay. And then hint, use the quadratic formula. I hope so, because 2.5 is... That's 2.5, by the way, not 25x. And then use the quadratic equation. Set the equation equal to 0 before using the formula. This is one of the bigger issues that people always tend to forget, that it has to be equal to 0 before you even start. So to begin with, you have to subtract. My advice is you want to get the right side equal to 0, so you have to subtract 12.5 on both sides, minus 12.5. So if you rewrite this, it's 3x squared plus 2.5x minus 12.5 is equal to 0. All right. So your A is the 3, right? Your B is the 2.5, and your C is technically 12.5 negative. And if you plug all those in, oh my goodness, I don't even know what we're going to get. It doesn't give us an answer, so let's see if we're correct or not. Okay, I'm just going to set this up. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, so x equals. And we're going to plug stuff in. Let's see, we've got 3, oh my goodness, I lied. 2.5 is the b. 2.5, a is 3, c is negative 12.5, and 2 times a, so that's going to be a 3 down here. Okay, did I plug those in? I really hope I plugged those in correctly. So x equals negative 2.5 plus or minus the square root. 2.5 squared should probably be 6.25. Negative 4 times 3 is negative 12. Negative 12 times negative 12.5. It should give you a positive. What are we at? A positive 150? Oh, I guess so. 150 all over 6. 2 times 3 is just 6. Sorry. And then you need 2 answers, right? As far as we know. So negative 2.5 plus or minus the square root of 6.25 plus 150. Wow, I can't believe I did that on the calculator. 156.25 all over 6. And then the square root of that is a really ugly. Oh, it's not bad. 2.5 plus or minus 12.5. all over 6. So I'm going to split this up right now. Negative 2.5 plus 12.5 all over 6. And x equals negative 2.5 minus 12.5 all over 6. Okay, and I'm going to stop there. And please finish these out. So what is x actually equal to? What is x actually equal to as the numerical values? Because we need them for the x-intercepts. They need to be an actual answer. Okay, so feel free to go back. I'll see you guys tomorrow.